Dear students, in day-to-day life, you come across some temporary, physical, and some permanent or chemical changes practically every day. Classify the changes given below into physical and chemical changes. Situation, physical change, chemical change. Ice changes to water is a physical change. Milk is set to curd is a chemical change. Ripening of fruit is a chemical change. Steam condensed is a physical change. Your respiration is a physical change. Sometimes substances, that is reactants, react to form a new substance, that is product, which in turn is able to form original substance under certain conditions. This is a temporary change. For example, water freezes to ice. On heating, it forms water again. When reactants are permanently converted into a new product, chemical change takes place. A ripe mango cannot be made raw again. When a chemical change occurs, a chemical reaction takes place. Let us perform some activities. Activity 1. Take a tablespoonful of copper powder in a china dish. Heat it strongly. What changes do you observe? A black substance is formed, which is copper oxide. The reaction is given as 2Cu plus O2 gives 2CuO. Let us fill this table. Change in color. Reddish brown to black. Evolution of gas. No gas evolved. Change in temperature. No change in temperature. Change in state. No change in state. Activity 2. Take a small piece of aluminium wire and burn it. Record your observations. It cannot burn easily as aluminium reacts with air. A thin layer is formed on wire. This is aluminium oxide. Further reaction is not possible till oxide layer is removed. Let us note down the observation in this table. Change in color. It turns gray. Evolution of gas. No gas evolved. Change in temperature. No change in temperature. Change in state. No change in state. Remove a tungsten wire from a fused bulb. Try to ignite it. What do you observe? It does not ignite. Activity 3. Take barium sulfate solution in a test tube. Take potassium chromate solution in another test tube. Add potassium chromate slowly to barium sulfate solution. A yellow precipitate of barium chromate is formed along with potassium sulfate solution. Barium sulfate plus potassium chromate gives barium chromate plus potassium sulfate. Let us fill this table. Change in color. Color changes from white to yellow. Evolution of gas. No gas evolved. Change in temperature. No change in temperature. Change in state. From liquid to solid. Activity 4. Take some dilute sulfuric acid in a test tube. Take some iron sulfide solution in another test tube. Add a small quantity of dilute sulfuric acid to iron sulfide very slowly under supervision of your teacher. Touch the test tube. Also experience the odor. What do you observe? There is a change in odor, temperature and color. You get the smell of rotten eggs from H2S. Let us note down the observation in this table. Change in color from blackish grey to green. Evolution of gas. H2S gas is evolved. Change in temperature. Test tube gets hot. Change in state from liquid to solid and gas. Activity 5. Heat camphor in a porcelain dish. Keep a funnel plugged with cotton over the dish before you heat. What do you observe when camphor burns? We can see vapors rising. What happens when the apparatus is cooled? The vapors cool and stick to the sides of the funnel. Let us note down the observation in this table. Change in color from white to black soot. Evolution of gas, vapors of camphor arise. Change in temperature, no change in temperature. Change in state, from solid to gas. A chemical change accompanied by chemical reaction not only changes nature and appearance of the reactants, but also changes the identity of the reactants by bringing about change in color, temperature, state of the substance, and sometimes evolution of gas. Example, salt obtained from seawater. Every action is an activity. Each activity with chemical change results in a chemical reaction, which is represented by a chemical equation. Let us see what is meant by chemical equation. You all must have heard about National Council of Education Research and Training, National Environmental and Engineering Research Institute, Bharat Sanchar Nigam Limited. Their abbreviated forms, that is NCERT, NEERI, BSNL, are convenient and easy to remember, isn't it? Let us take a reaction. Say, when copper powder is heated, black copper oxide is formed. We can represent it as copper plus oxygen gives copper oxide. Representing chemical reactions in words is called a word equation. Let us see how to write a chemical equation. During the reaction, the substances that undergo change are called reactants. In above equation, copper and oxygen are the reactants, which react together to form a totally new black-colored substance, copper oxide, which is a product of the reaction. The reactants are always represented on left-hand side, whereas the products are on the right-hand side of the equation. An arrow in between them always points towards the product and tail towards the reactants. The arrow also represents the direction of the reaction. If there are two or more reactants or products formed, they are written with a plus sign in between them. For example, when you mix vegetable oil with nickel powder as a catalyst and heat it with hydrogen gas, fats are obtained on cooling. When oils get converted to fats, the reaction is to be carried out in presence of nickel, which acts as a catalyst at high temperature. Certain reactions have to be carried out under specific conditions of temperature, pressure, and catalyst. These conditions are mentioned on the arrow pointing from reactants to product. The physical states of the reactants and products are to be mentioned in the chemical equation when necessary to make it more informative. The gaseous, liquid, and solid states are symbolized as G, L, and S respectively. Edible oil, a liquid, plus hydrogen gas on heating gives fats a solid. If you observe that the reactants or products are present as solution in excess of water, what symbol do you use to represent it? We use the symbol AQ for aqueous. Let us consider equation Cu plus O2 gives CuO. Count the number of atoms of each element on both reactant and product side. Is the number of atoms of each element same on both sides? If not balanced, it is due to the unequal mass of the atoms on both sides. In such a situation, the equation can only be the skeletal chemical equation for burning of copper to form copper oxide. Let us see how balancing of the chemical equation is done. Let us take the word equation iron sulfide plus sulfuric acid gives ferrous sulfate plus hydrogen sulfide. Its chemical equation can be represented as FeS plus H2SO4 gives FeSO4 plus H2S. The table shows that there is one iron atom each on left and right sides, two sulfur atoms on both sides, 2 hydrogen atoms on both sides and 4 oxygen atoms on both sides of the equation. When number of atoms are the same on the LHS or left-hand side and RHS or right-hand side of the chemical equation, then the equation is said to be a balanced equation. Let us now see the steps involved in balancing any equation. To get a balanced equation, there are a number of steps. Try to balance the following equation. SO2 plus H2S gives S plus H2O. Step 1. Rewrite the given equation as it is. SO2 plus H2S gives S plus H2O. Step 2. Compare number of atoms of each element in the given equation on both sides of the equation. We can see there are 2 sulfur atoms on left side and 1 sulfur atom on right side, 2 hydrogen atoms on both sides, 2 oxygen atoms on left and 1 atom on right side. Step 3. Choose the reactant or product having maximum number of atoms. In the given equation, select SO2 and the element oxygen in it. You have already noted that there are 2 oxygen atoms on LHS and only 1 on RHS. Equalize the number of oxygen atoms to balance there. While equalizing the number, remember that you cannot change the formulae. That is, to balance 2 oxygen atoms, do not make H2O as H2O2, but change the coefficient of the complete molecule of the deficient side, whether LHS or RHS. In your given equation, the deficient side is right-hand side H2O molecule. Hence, put proper coefficient 2 for H2O molecule to balance oxygen atom, that is 2H2O. Your partly balanced equation can now be expressed as SO2 plus H2S gives S plus 2H2O. Step 4. S and H atoms are not yet balanced. You may select any one of the 2. Select hydrogen atoms for balancing. Let us equalize the number of hydrogen atoms. There are 2 hydrogen atoms in reactants and 4 in products. We multiply 2 in H2S by 2 to balance. Make the number of H2S molecules on left side as 2H2S to get balanced hydrogen atoms. Equation would now be SO2 plus 2H2S gives S plus 2H2O. Step 5. You now need to select S, the only element left to be balanced. Atoms of S in reactant is 3, that is 1 in SO2 and 2 in H2S. In product, there is only 1 in S. We multiply 1 by 3 in right side. To equalize number of sulfur atoms, you can make 3 atoms of sulfur on right side. SO2 plus 2H2S gives 3S plus 2H2O. Step 6. Count the number of atoms of each element in equation on left side and right side. There are 3 sulfur atoms, 4 hydrogen atoms, 2 oxygen atoms on both sides. You will notice the number of atoms are same. Hence, equation is a balanced chemical equation. Please indicate the physical states of reactant and product when necessary as mentioned previously. SO2 gas plus H2S gas gives 3S solid plus 2H2O liquid. The conditions of the reaction, if any, are to be indicated above and below the arrow between left side and right side. For example, in the given equation, 323 stands for temperature. Reaction takes place with alcoholic concentrated hydrochloric acid, which is shown above the arrow.